So once again, good afternoon. Today I'm going to finish the architectural patterns, which is not a very long topic. And after this topic, we will have one more topic, and that will be it. This means that we don't have much to go. I'm sharing my screen with you right now. We will only have, after this one topic, and having done so, after finishing these topics, you will take the final exam. So this is what I want to discuss today. Your final exam will be online. This means that you will, additionally, when you submit the projects, we will set up a final exam date, which will be available to you on Moodle. Yes, on Moodle, also on SIS, and you will take the final exam. The final exam will be 20 questions, and all of them will be multiple choice, okay? The questions you're going to take will be done on Moodle, so you must be registered to Moodle in order to take the final exam. If you have debt issues to the university, you need to fix that in order to see your marks, because I will upload all of the marks, including your project results, to SIS. I will never ever upload anything on Moodle in terms of marks, okay? Just so you know. You follow your marks on SIS. The exam format, as I told you, will be a multiple choice, 20 questions. However, there's a trick here. The questions will be randomly distributed. This means that, for example, the questions Darlington Daniel sees will be different than the questions Sostenes sees. The order will be different. The options will be different. One of the restrictions I will put into exam is called sequential navigation, which means you cannot skip a question and come back to it. This is going to be a restriction on you, which means that as soon as you see a question, before you go to a next question, you need to answer it. It must be done as a restriction because in the other groups that I teach in the Introduction to Programming class, which gave me a help this term, I didn't do this option, and a lot of people formed WhatsApp groups and cheated in that exam, which created a lot of drama for us. And as a department, as the computer engineering department, we have taken the decision that all exams that we're gonna arrange on Moodle must be sequential order in order to minimize the cheatings done in the exam. This is a nuance. This is something that I really don't like to put, but unfortunately, students in our university, not of course all of them, but some students, do everything in the exams to teach and convert this pandemic situation into their advantage. I don't like these kind of people, okay? I don't like that they pass in front of hardworking students who have done everything they can to get a good mark. So unfortunately, I will put these restrictions on you, to also some JavaScript restrictions, such as the exam will be open up in a pop-up window. And we will also track down the devices that you access, such as a mobile phone or a desktop computer. I really suggest you to take the exam on a computer, but it will be possible to take the exam also on a mobile device, okay? And as I told you, for the 20 minutes, I will give you around 30 minutes to finish the exam. This means that for each question, you gotta spend over 1 minute to answer. The questions will be very straightforward, such as definitions given. I will leave a blank space and you will have to complete that definition. Or I will ask you which one of the following is not a software architecture used in software engineering, and you will have a couple of options down there, and you will pick up the one that we did not cover or we did not list as an architecture, okay? That is the question style. So in terms of evaluation of this course, you have two projects. One of them you already submitted, and this week I will announce your results, hopefully. And the second project is upcoming. You're going to submit that one too. And finally, after you submit the second project, you will have a final exam. The final exam, as I said, once again, I'm repeating myself a lot so that no one asks the same questions again and again. The exam will be multiple choice and it will be available. The date it will be available on SIS when this is ready. Right now, I don't know the dates because I don't set them up. A centralized system will do that so that you have no clashes with other courses about the final exams. When the dates are announced, we'll see them on SIS. Okay? Now, any questions before I start to today's lecture? Please raise your hand so we can talk, guys. I have several screens in front of me. It's best if we actually talk to each other. Yashar, you have a question. Yashar Sinan. No, Yashar. Unfortunately, you are not supposed to do this project alone. You are supposed to do it with people who you work with in the first project. Okay, it's the same people that you are supposed to do it with. If you submitted the first project, you need to work with those people because essentially the topic is the same. It's just that what you do with that topic is going to be different. In the first one, you used an agile development method. In this one, you are using a plan-driven development. Okay? So if you work with the people in the first project, then you got to work with them now. That is the solution. And everyone should have a group by now. It's a little bit odd that we have only 1 week left and you still don't have a group. Okay, what can I say? You can ask to the other groups if they need a extra hand, and you can do the project on yourself with them. But you are not allowed to submit by yourself. Okay, this is the procedure given in this course from the very beginning. I told you this. Okay, so it's something that you got to come up with. I also created a form on Moodle in case that there's people check it and want to give you a hand about this. Please talk to your classmates. They might need some help or might give you extra task so you can be involved. As for today, I want to start with the client-server architecture before my battery runs out on my computer. In the previous lecture, we covered the layered architecture and we also covered the MVC, as you know. And today we're going to cover the rest of the architectural models. The client-server architecture is the next one in our hand that we need to talk about. This is something that you know from the network courses as well. You are taking the Evermojas class. I am assuming you took it. So you know from the client-server architecture design from there. It is a distributed system architecture, which means a collection of independent computers connect through a network. Sometimes we regard the client server as also the distributed architecture. And many of the services, the web services that you subscribe or use, follow this kind of architecture. A big example to this is, of course, Netflix. The way that Netflix works is that the servers are actually localized or distributed, as we can call them, and based on the agreements that the uh, TV channels have in that country, the shows actually change. So some show seasons can be different from others because they are under the contract with some TV channels, and it will be difficult for Netflix to breach that contract and to put the shows there. So this is why they need a localized system that can be adapted for each country or at least for each region. This requires the necessity for the distributed systems. When the system is distributed, there is no such thing as the main server. What it does is, according to your location, it tries to access to the closest service that it can offer to you. And based on your location, that service responds to your request, and it is an independent service from the other ones. So just because you live in Cyprus and you want to access to the services on Netflix, you are actually not disturbing the services in Canada or in England or any other country. Okay. So this type of architecture has one or more client computers, obviously, connected to a localized or distributed service. And when you actually connect to it, there is a connection in between the two. And as the client asks for services, the servers respond to this. There are many big services that can provide this architecture. Of course, Netflix is such a big service that it has grown much more than a distributed system now. But at its core, Netflix works as a distributed service. This is why we can give it as an example to the client-server architecture. So when we look at the description, we know that the functionality of the system is organized into services. So it is not a product, it is the service that you are getting. And the client's access to the localized services so that they can provide you this service. There are certain advantages and disadvantages to this model. Just like with all other models, there is a price and there is a strength. So the advantage of this model is that each of these services are actually independent. So general functionalities, it can be available to all clients, where you can actually separate some of the localized services. So again, when we go back to the Netflix example, I'm assuming that you all watch at some point Netflix, or maybe you still do, or you are fond of it. So basically, how it works is some of the main services of Netflix, such as the shows that they do not have to, come to a contract because they produce those shows, are available in every single region because they pay the price for it. So they make them available regardless of your location. Specific shows or movies that they produce will be available in every single country because they don't need to go to a contract. Where the other shows that Netflix has to run a contract with the TV channels of that specific country, has to undergo some procedures in order to offer it, such as if Netflix want to put a cartoon, and if the season 4 and season 5 is being in a contract on a TV channel, then Netflix will only be able to show 1, 2, and the third season only. This gives some functionality to Netflix because the services can be localized, and also some other services, such as the general functionality, can be kept all together. The disadvantage of this model is that when you have so many services, performance can be unpredictable because basically you are depending on a network, and there could be management problems as well because there are so many services that are being offered by this model. So it's not one server that can, dominate and manage. There are many different points that you need to manage at the same time, and it can be an overwhelming experience. And also the performance you get from this kind of model will heavily depend on a lot of variables, such as your network connection, the localized server that is produced in there, such as Netflix might decide that in this region, Netflix is not being watched, not as much as in Europe, for example. And while they invest into their services in Europe, they might not consider that much money in this region. So it's not like an equal portion of things. There are business side of these things, and hence why these are reflected as unpredictable performance or other failures to the clients. So in as a summary, if we shorten these things, the advantages is here is that you can now have more control of which services you can provide to clients. So even personalize the experience for them according to their location and whatsoever. But the disadvantage is this makes a complex manageable structure and some performance problems. Many web services, streaming services actually, can be regarded as client-server or distributed systems. This also includes YouTube. But I'm not saying that YouTube fits into this architecture or Netflix? Primarily, at its core, yes, it is. But you know that these stream services became so complex systems, such a big system that it doesn't fit into one architecture alone anymore. They are actually applying more than one architecture at a time. The In the client server architecture, we know that this type of model is particularly used with distributed systems, and the structure at its core is independent. The services and servers can be managed without affecting other parts of the system. So a failure that happens in this region is not going to affect any other region. So this is probably the biggest advantage of this model. Computer systems that have components distributed among a network are called distributed systems. Just so you don't know, a definition is given here. Most mobile computing and location-aware computing systems are actually distributed systems. For example, Facebook and Google services are a good example of distributed systems as well. But once again, remember that these services are so big right now. Any questions about distributed systems? To summarize, client-server architecture has the advantage that you can personalize the experience, and one failure does not really affect the other systems, but it has some performance problems. Also, management. So management is actually a good thing and a bad thing. It is a good thing because the services do not affect each other. So one failure will not affect another, but it is also a bad thing because it is complex. Any questions so far before we pass this architectural model? Yes, we can go into now the repository architecture. The repository architecture, in the last lectures, we talked about if you remember, cloud computing. Darlington mentioned it many times throughout this course. And repository architecture is an architectural model particularly for that purpose. Now, we know that cloud computing is not something new. It's an ongoing thing for the last 20 years or whatever. But its rise has been done particularly when the smartphones became more popular. Cloud services, actually, the need for them increased. With the impact of 2010 and afterwards, these services became much more reliable, and many of the things are being supported on the cloud side. Nowadays, we use the cloud basically to store information, such as taking our backups from our phones, or use a repository, which means storage units, where we can keep our data. In our personalized life, these come as examples that we see from OneDrive, from Dropbox, and other examples. But repository architecture in a couple of years has taken a huge impact in the software development. That with the rise of GitHub and other software services, it is now being developed into something much more. It is not storing the data anymore, but rather it is becoming a platform where multiple people can contribute and work on a project. This gives advantage, particularly in a world where we are separated like this, where we have a social distance, but we still need to work together. And that is why the repository architecture's crucial part has become a major factor. With the rise of other kind of data, such as big data that is got from all these services that listen the user behavior, repository architectural design has become really, really popular nowadays, and probably it's going to be popular for the next couple of years as well, until it just finds its place more and more in the industry. So what does this architecture means? It is basically at its core produce large volumes of information generated and used for a long time. It is also useful when triggers a tool or an action. There are multiple use of repository architecture nowadays. As I said, one way our personalized use is, well, it is at its core, that's how it started, to store data, like on OneDrive or Dropbox or other services. But like I said, now with the rise of big data, which is basically listening your behavior with machine learning, some big chunks of data is generated from the user behavior, and now these are being stored on a cloud server, and then based on your behavior, advertisement suggestions are being presented to you. And that is the one of the major use of the repository architecture nowadays. Another usage is, as I said, like if you want to work on a project such as you are developing an interactive tool or a game in Unity or Unreal, you can now put that project in one place and multiple users can pick it up from the very last version, like what you do in GitHub, and work on it. Almost all systems today that we use, they provide some sort of cloud and management services. So even the small apps that you use, they are able to, for example, store some previous chat data even when you delete the app on your phone. So these kind of information used to be very localized on your phone in the old days, but now they have services that you can upload them to a cloud. So even when you delete WhatsApp, for example, from your phone and reinstall it, you still get the history from the other people. So let's look at the our repository architecture. What it does is, as we described, it's a business need. It rise as for storing data, but it changed over the years so much more. So whenever you basically connect, there's a mapper to your information, and the information is being stored at some place, and you always get the mapper to the information, such as you can think of it like a shortcut. And whenever you want to access the data source, you get a query object. And every single one of these is done through a business entity. Repository architecture is very, very useful because, for example, when you buy a new phone and you want to transfer all your WhatsApp contacts and your history with them. This is now, in the old days, you have to go through a manual process of backing up your phone. And once you have backed up the phone, you have to put that backup into the new phone so that you can continue using it. But now this can be done even without that procedure, because many of the apps that you use today have some sort of cloud, which means as long as you prove that you are the person using that WhatsApp account, it is possible to access all the historical events, even pictures and chats that you have with people. So it is basically, there is no need to transmit data explicitly from one component to the other, which means from if you work on Dropbox, for example, on your computer, and you save a file and you go to another computer, such as to my work computer, let's say, the data will be there. So I don't have to manually transfer it. It is done automatically. I just need to access to that service, which is basically what we said in the previous example as the data mapper. So the data is stored somewhere, and each time we access it, we need a data mapper. So this is a great advantage of this model, and it's at its core, that is how it is developed. However, it is not an easy task to distribute the repository architecture to a number of machines. Some of the problems with repository architecture, it used to be very inconsistent. Now it is discussed that it is not very secure. So security is probably one of the things that that can be still breached with repository architecture and needs to be strengthened. There are specific advantages to this architecture, of course. One of the big advantages is, as you know, uh, is the independence of the platform you access it. This gives you a very good advantage because it does not matter anymore which device you use to access that information. Okay, so you can arrange the data as you like in one device, and whenever you access to that data again, you don't have to go worry about your last access. It will be done automatically because at the background, the data is being changed through a data mapper. So it also reduces the, how do I say, it is also reduces the possibility of corruption of data, which is basically another reason why repository architecture got really, really popular. So if you mess up your own computer, let's say, and somehow Windows does not work and your data is corrupted and you had your homeworks, thesis, whatsoever in it, you'll be worried about it because you know what, if you cannot save that computer, all that homework and everything you have done is gone. But with the repository data, the corruption doesn't happen because if the data is corrupted, it is not even copied because you are also using a map to the original data. And if the save is not done properly, then it will not override it. So it's also adding a layer on the top of it to make sure that data stays consistent. Okay. However, there are some disadvantages. This used to be an unreliable technology. I remember when I wrote my PhD thesis back in 2013, 7 years ago, I had a personal experience on Google Drive. I saved my thesis at my work. I was in England at the time. I saved my work in the university. I was very happy, almost completed my thesis. And it showed me that the Google, driver put a check next to the file that I saved. Now I shut down the computer and I went home. I ate, I went to gym. I came back to look at my thesis around midnight again, and I saw that despite the fact that it put the check, it didn't actually save all the information that I did during the day. And I was like pulling the hair on my head, like, what am I going to do? All that effort is gone. Despite the fact that it used to show that it's saved, sometimes this didn't happen 9 years ago when these services were becoming really popular. But nowadays, this is not the case. I don't have any bad experiences lately with Google Drive or Dropbox or other services that I use, and they are became really reliable. As soon as it shows that it saves, it actually does it, and it works much faster than before, for sure. Like I will have to wait like straight 5 minutes for a worthwhile to properly be saved. Nowadays, it's just done in seconds, which is great. However, there are some problems with this architecture. One of them is the model for being very vulnerable. And I think this is kind of like an active research area that you can look into if you want to do a master degree or a PhD in the future. Cybersecurity is probably one of the things that need to be developed further in repository architecture, because everyone's in a couple of years like ago, you will remember that some pictures that celebrities uploaded to their iCloud was stolen, some data that was leaked and stuff like this. So it's like not really that difficult for people who know what they're doing to hack these kind of systems. So it's not like the best security out there for these services. I would say it is still an active research area. So it is a vulnerable, I think the correct word is it's a vulnerable design for now. But we don't know what's going to happen. Technology changes so fast. 7, 8 years ago, these technologies weren't very reliable, and they are reliable right now. So I think in the next 5 years, repository architecture will be really, really reliable and strong. So if you look, for example, someone asked me in this course, what are the fields that are really actively popular nowadays in the world of IT? This is one of those fields that is really popular. Cybersecurity and AI, like basically developing an AI to provide the security of a service is a really popular area, and it will earn you hell a lot of money. Like you will make thousands of dollars if you get into one of these businesses. Okay. Yes, Daniel.
Sorry, I just wanted to ask, is Google Stadia classified under this kind of architecture?
Google Stadia is now a service being developed for gaming, as far as I know. So the idea here is a streaming service. So I will put it under the category of distributed systems, not repository architecture, because essentially at its core, it's like the gaming version of Netflix. Basically, what they want to do is to provide a gaming platform. So you will just use your television or whatever device you have, like a smartphone or a computer, and you will play games just like we do on Netflix. So we can watch our Netflix. How many of you use Netflix? Can you raise hand on the platform if you use Netflix? So two. Any other? Three. Nice. So a couple of people are using Netflix, so you know what I'm talking about then. So basically, you can watch Netflix on TV, on computer, even on your smartphone if you want to. And basically, Google Stadia aimed the same thing as a distributed system. So I will not put it into the repository architecture. However, we all seen that this is just another gadget and ambitious projects of Google once again. Whenever Google announces a project, I'm very suspicious about what they're gonna do because they are very ambitious nowadays, and the technology is not there yet. To offer streaming services for games that you can basically play it, and their business model is not helping to them either. So if they continue like this, I don't think Google services will be very successful. Okay, that's my idea about this. It's just another ambitious, over-the-top project from Google, which we had seen previously. Google Glass and their Google Plus. Again, something that they want, but the technology is not there yet, I think. And their business model of buying a game and also paying a streaming service at the same time is a bit too much. You can simply buy the games and play them on your computer without playing the service. So if I'm gonna, buy every single movie and also pay for Netflix every month, that doesn't make sense. So they have to change their business model for sure. Yes, Eze, you want to talk? You raised your hand, so I thought you wanted to talk. Just before I pass to pipe and filter architecture, I have 4 minutes in Zoom. So I'm gonna stop in here and re-invite you on Moodle. So the electricity came back, so that is an improvement, right? So I'm happy about that. Do you have any questions before I pass to pipe and filter? No. Good. I'm just stopping this now and I'll re-invite you on BB. So let's go back to BB and I'll send you an invitation. See you in a while.